So this is the sigma. Here the equation. This is the equation. This is the equation we have derived in the last class. Here the sigma KL. This is the method of writing a transform stress in the transformed axis to the stress in the primed axis. Don't disturb me. Please mute. Okay. Yes. So this is the prime. This is the main equation to writing. This is the main equation for the transformed axis. The relationship between the transformed axis and the non-transformed, although that is called the prime axis. Prime in the stresses in the prime axis and the stress between of the transformed axis. If we have the we have to calculate the stress in the transformed axis. That means we are taking the x dash, y dash, z dash, whatever it may be. So in that case, how the stress will be correlated, that will be written as sigma KL equals to a KI ALI and sigma IJ. What is the sigma IJ? Sigma is the stress on the primed axes or the primed coordinate systems. That is sigma, that is x, y, and z. So this is the stress in these respective axes, and when these axes will be transformed, so this will be the stress in the transform axis. So in that way, we'll write these equations. So when we're writing these equations now, some certain things will be in mind. So what is the method, the best method of writing these equations? No need to, the meaning of this stress tensor is to, but to making easy of you the complicated stress in three-dimensional cases, making the complicacy to resolve the complicacy in the three-dimensional stress system cases. So how easily we can write down these equations? That is the main merits of the stress transformation equations or the tensor equations. So again, I'm writing this equation what is the method, best method? When we are writing the sigma KL, that means there are. That means it is a second rank tensor. It is a second rank tensor. So though it is a stress is a second rank tensor here, the conditions of the second rank tensor. So we will write A for, we will write only 2A here. Then what we will write? The one is for 1A with side K, another with L. Then the multiplication, then we'll making the relationship with the prime stress, the stress at the prime axis, that is sigma ij, that we have already, we have that stress already. So in terms of that, we will write here, write here I, we write here I, and here we will j. This is the method of writing a transformation axis, the stress tensor equation. Okay. So as we know that here I is the free suffix, I is the free suffix, and j is the dummy suffix. So please don't be confusing here that what is sigma KL. The important thing is what is sigma KL and what is sigma IJ. Don't be confused over here. Sigma Ij is the stress. It's the stress in the primed axes or the coordinate system already taken. The stress, existing stress at the primed axes. Whereas the sigma KL is the stress transformed, the stresses at the transformed axes. So the main aim of this tensor equation is to find out the stresses at the transform axis. How easily we can find out this. So if you are using the I and J, the dummy suffix and the free suffixes here, na. So J is the summation over the first sum over J is 1, 2, 3. If you are putting that J is the J is the dummy suffix, we will put J summations over J. We put first to expanding the tensor equation, expanding the tensor equation, we'll put j is equal to 1, sum over j is equal to 1, 2, 3. To sum over j is equal to 1, 2, 3. If you are putting the sum is equal to 1, 2, 3 in this equation, this is your equation, prime equation. This is the main equation. Okay. This is the main equation. So here we will go for the j is equal to 1, 2, 3. So equation can be written over here. Sigma KL equals to what? A K I. So here A K I is there. Then A K first. Sorry, A L. A L. This A L. A L J is 1 and sigma I J. Sigma I and J is 1. Similarly, equation with the summation over J is equal to 1, 2, 3. We'll take in the sum over J is equal to 1, 2, 3. Again, A K I A L2. I'm checking the screen. AL2 plus sorry, sigma I2. This is I sigma I2 plus AKI AL3 sigma I3. This is the equation. Summation over j is equal to 1, 2, 3. Similarly, now summing over I is equal to 1, 2, 3. Now sum over I is equal to 1, 2, 3. No, sum over I is equal to 1, 2, 3. Sum over I is equal to 1, 2, 3. Now similarly, now we can just put the values of I 1, 2, 3 in this above equation. In this above equation, we are putting this here. So equation could be written as sigma KL equals to your A K I is equal to 1 A L sorry, this is A L 1 sigma 1 1 I, you are putting I is equal to 1. Similarly, A K 2 A L 2 plus sorry, no, plus sigma j is equal to 1 na? Now, just rewriting this equation because it will be easy for you. I am writing in other format. It will be better easy for you. Sigma A1, sigma A, sorry, AK1, AL1, sigma 1, 1. Then I am writing, let's just see here, sigma, sorry, again, AK1, AL2. I'm just putting L is equal to 2. AL2, I is equal to 2. Sorry, summation over I and J is here also. AL2 into sigma 1, 2. See, sigma 1, 2. Then see here AK1 AL2 sigma 1, 3. Similarly, I'm writing here. Similarly, if I'm writing here, just making a small visibility, I'm making it small. So just zooming out it. Similarly, I'm writing AK2 AL2 sigma I am putting I is equal to 2 now. When I put I is equal to 2, then it will be 2, 1. Sorry, we have j is equal to 1 here. J is equal to 1 here also. If j is equal to 1 here, then we will write out here 1, 2, 1 plus a k2 a l2 sigma 2 2. Similarly, I'm writing here a k2 a l2 sorry al3 na al3 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 sigma 2 3. Okay. Similarly, you can write this equation also in the same manner. In the same manner, we are writing this equation. K3, AK3, AL1, AL1, sigma 3 1 plus AK3, AL2, sigma 3 2 plus AK3, this side, AK3, L3, sigma 3 3. How many of you can understand this equation? How many of you can understand this equation? Now tell me. First, I have taken the sum over j is equal to 1, 2, 3. This is the equation. First, see this equation. J is equal to 1, 2, 3. First, see this equation. Then I am taking I is equal to 1, 2, 3. Here, j is equal to 1, 2, 3. But by putting j is equal to 1, 2, 3, this is the equation. This is the first equation I have here. Okay. Then after that, j is equal to 1, 2, 3, taking sum over the I is equal to 1, 2, 3. So I is equal to 1, 2, 3 means first j, we are taking j is equal to 1, 2, 3. In every equation, we are putting I is equal to 1, then I is equal to 2, then I is equal to 3. Then we have three sets of equation. We have three lines of equation, three sets of equation. So this is mathematical relations. Nothing else. These are all other mathematical relations. So here we see here the sigma KL. Sigma KL. So for each values of K and L, for each values of K and L, there is some equation. For each values of K and L, so there will be some values and the equation will be something. Okay. To find out the equation, if the question arises here, what is that? If you are putting, if you are trying to put the values of K and L, if we put the values of K and L, so how can we put the values of K and L? So how can we put these values of K and L? If I am trying to calculate the stress in the transformed axis of x dash, we have the values of x, stress in x, but I need to calculate the value in x dash, the transformed axis, this x dash axis. So what is the value of K and L there? If I am taking the axis is x dash, the x dash direction, we need to calculate the stresses in stress tensor components in the transformed axis of x dash. Then what is the values of K and L? Simply, if we have that axis of x dash, then we have values of K is equal to 1, and L is equal to 1. Both are 1. Similarly, if you are telling only about the Similarly, if you are telling only about the axis of y dash, if you are telling about that y dash, then we have k is equal to 2 and L is equal to 2. If I am talking about the z dash, then k is equal to 3 and L is equal to 3. In the above cases, what we will write? We are writing sigma kl. We are writing the equation sigma kl. So you can write the equation in that format: sigma, either sigma 1 1 or sigma 1 2, sorry, sigma 2 2. This is not 1 2. How to write 1 2? I'll tell you. Sigma 1 1, sigma 2 2, or sigma 3 3. The equations can be written. So now by putting the values of k and l in this equations, in this above equation, by putting the values of the k and l in the above equation, this is equation number 2. This is a second equation. By putting the values of sigma and L in these equations, so we can now easily calculate this stress tensor components, each of the components we can calculate that easily. So this is the case to how to calculate the stress tensor components. This is the case of how to calculate the stress tensor components. So the question arises here also. Just I'm zooming out it. Okay, zooming in it. So if I'm talking about the x dash, y dash, and z dash, if I'm talking about the stresses on x dash and y dash plane, if we are talking about the stress on x dash and y dash plane, so if you are talking about x dash and y dash plane, both combinedly, so what will be the component? What will be k and what will be l? So k will be 1 and L will be 2. So what will be the stress there now? No, it will not the stress, it will be the shear stress, that is sigma 1 2, or we can say that is called as sigma xy. See, otherwise it will be called as sigma xy. Similarly, if it is y dash and z dash, then it will be written as k is equal to 2 and L is equal to 3, and it will be tau yz or tau 2 3. Okay, so I think it will now easy for you to calculate the values of different stresses and shear stresses from the above equation. This is our equation number 2 from the second equation. So you can calculate all the values of stress and shear stresses from this above equations. So if you putting the is you will try to if you will allow me to, then I will also write this equation for sigma 1 1. I'm just writing this equations for sigma 1 1 here. So other equations we will try to write down this. I'll write the equation for sigma 1 1 also. In place of sigma KL, I am putting sigma 1 1. Okay. So I'm writing this sigma KL. Sigma KL, if k is equal to 1, if k is equal to 1 and L is equal to 1, then we have sigma 1 1. The equation is written in the format is like that. A11 from the equation 2, A11 is only to put the values of k and L in the above equation 2. So A11, it will be also A11, then sigma 11 plus A11 A12 sigma 12 plus A11 A13 sigma 13. Similarly, we are writing here A12 A 1 1 sigma 2 1 plus a 1 2 a 1 2 sigma 2 2 plus a 1 2 a 1 3 sigma 2 3 plus a 1 3 a 1 1 sigma 3 1 plus a 1 3 a 1 2 sigma 3 2 plus a 1 3 a 1 3 sigma 3 3. This is the equation. See, this is the equation of sigma 1 1. How easily you can write these equations? Once you have to learn the writing, learn the way of writing the equations. This is all the mathematical relationships, nothing else here. So, if you once you have to learn the method of writing these equations, now it will be very easy for you to calculate any values of stress. Transform axis stress. It is very easy for you to calculate any values of stress. So in the same case also you can also calculate the shear stresses. Shear stresses means if I am choosing that sigma k is equal to 1 and L is equal to 3, that means it will be sigma 1 3, or sigma 1 3 means that is tau x z. We are now putting the values of k and L in these equations, in the above equations, and we can easily calculate this. All the values of can be calculated. The shear stresses can be calculated. Similar. This is the method of writing a second rank tensor. This is the method of writing the tensor components of a second rank tensor. So the transformation of a second rank tensor could just be well written as how can we write these equations, how usefully we can write these equations. So till now, if you have any doubt, you can ask me questions during the classes. Otherwise, I'll proceed on. So the transformation of a second rank tensor could just be written as, how can we who is disturbing this? Chandrasekhar Das. Okay. So, how easily the transformation of a second hand tensor could just be written? There is no mathematical, there is no concept of stress and strains. There is nothing related to the plasticity, elasticity. But just you have to take the notations and write the equations, nothing else. So, for example, I am writing here for you. See here. Someone I am writing is some second rank tensor. If there is a second rank tensor of TST, I am writing TST. How can I write that T dash ST? If it is a second rank tensor, then we will write 2A first. 2A. So one A with the suffixes, another A with suffix T. Then if we are writing when we are writing T dash ST now, so that means there will be some value before that. It will be transformed. This is the we are going to the by calculating. This is the transformed axis, the transformation value. So there will must be original value. That original value, if you are using the notation ST here, so for that original value, I am writing that PQ. Writing that PQ. So what are the suffixes used in PQ? So that will be represented. The both the suffixes will be represented here in that manner. Is it understandable for you? Is it okay or not? So the question is that T, PQ are the components in the original unprimed axes. The T, PQ, original components of original unprimed axes. Okay. Axes, what are the axes that are on prime, that they are not transformed anywhere. So T dash ST are the components refer to new primed axes. This is refer to new primed axes. New primed axes. Primed axes. And what is that TPQ? It is on primed axis. On primed axis. So I think you can write any format of equations, any value of equations in the same format. In this same format, I think you can write that. Okay. So if there is a, this is a second rank tensor. This is a second rank tensor. This is a question of the second rank tensor. If there is a third rank tensor, then how can you write this? For example, we have a third rank tensor. This is the second rank. If there is a third rank tensor, if there is a third rank tensor, then how can we write the equation? For third rank tensor, I am supposed I am making it is ST. So I am writing it STU. Okay, T dash STU. So then the method of writing tensor. So first 3A, third rank tensor. No, I am writing third rank tensor. So one with S, one with T, and one with U. Then there is the unprimed axes. There is the values of unprimed axes. So values on unprimed axes, I am writing that is in previous equation. I am writing TPQ. So here I am writing TPQR. So simply now write down this S with P, this P, then T with Q, second, then third with third, Q with third. How easily we can write any transformed axes. Okay, can you understand? Can you write these equations? Can write. Okay, so you have gained the what we have obtained here, that a useful technique for transforming a tensor quantity from one set of axes to another axis. It is a useful equations. It is not a equation. We can say it is a technique. That is a useful technique for the transforming a tensor quantity from a set of one set of axes to the another set of axes. Suppose we have telling about x, y, and z axis, and there is a transformation is that x dash, y dash, and z dash. So how easily we can write this type of equations by the tensor notations? So there are only a few additional facts about tensor that we need to consider only. So there is, during the tensor there is another important operator is there. In a tensor theory, there is a operator is there that is called as Nacos delta. So what is that Nacos delta? We'll see here now. What is that Nacos delta? There is in stress tension theory, there is a term that is called as Nacos delta. Nacos delta. Nacos delta. The symbol used is delta ij. The notation used here is the knockout delta sigma ij. So what is that knockout delta? Knockout delta is a second rank unit isotropic tensor. It is a unit isotropic tensor. It is a unit isotropic tensor. Its determinant values are like that 1 0 0 1 0 1 0, then 0 0 1. Okay. It is a unit isot second rank. It's a, what is that? It's a second rank unity unit, then isotropic tensor. Unit second rank unit isotropic tensor quantity, Nacos delta. So its values will be of two values to most optimum values we can obtain here. One is 1 and other is 0. You will got 0 if I is not equals to j, I is not equals to j, and 1 will be got when I equals to j. Okay, we have got two maximum values of this from this first delta. So what is the question I just here? Why I am introducing here the Nakos delta to you, and what is the importance of Nakos delta in the tensor theory? So Nakos delta is otherwise known as a Nakos delta is otherwise known as this Nakos delta is otherwise known as a contraction vector. Is a contraction known as contraction. So contracting, it will that this Nakos delta will be contracting any tensor quantity. The Nakos delta is used for the contraction of the tensor. It's called the contraction of the tensor. Contraction of the tensor. Contraction of the tensor. It is called as the contraction of the tensor. So we have less than 1 minute. We will rejoin after the end of the meeting. Okay, I'll start again this meeting, and then you have to rejoin that. So it is called as a contraction of the tensor. Contraction means what? That means reducing. If some quantity has a tensor of fourth rank tensor, if we'll multiply the Nakos delta there, then the tensor, then the rank of the tensor quantity will be reducing there. That's why it is called as a contraction tensor, or it will be also called as the reducing tensor. Reduction. That will be reducing the rank of that component. Okay. So we'll see how it will be reducing the rank of this tensor quantity. Okay. So